Thank you, everyone, and thanks for the meeting organizer to help us for us to come here. It's a pleasure to be here. And I also want to thank Sarah Pollack, who was involved with all these communication, but she's not here today. Although she's hearing it, I hope. Okay. So I'm, as Sibo said, I'm passionate about BioEM talks. And I'm just going to have a very quick introduction about BioEM talk. We have a website. You can find out all the information. The reason I'm here is I want to be connected with this group of scientists. And so BioEM talk is really emphasizing on sharing. So our virtual webinar is completely free. And every presentation is recorded. It's also on the YouTube website that for people to access. Okay, so we like to venture into, because not only we talk about science, it's really technique-oriented instrument. And when we started BioEM talk, it was during pandemic. So we actually stopped 1 year, but people keep telling me which we should restart, because a lot of us are having trouble with budget, and people have limited budget to travel to attend meeting. And also, even when you have meetings, often the people who actually work on the bench do not get to go to any meetings. So I want to have a forum for them to get access to the most up-to-date technique and instrument. So we decided to bring it on the virtual platform for them. So since 2019, we have grown into like more than 600 members internationally. So we not only discuss techniques, instrument, we also talk about career, education, and identify the problem. So that's why we are here, and we want to learn, and we want to gather together. And mostly we promote resin-based electron microscopy. We kind of separate us from cryo-EM because we felt there's a lot of education opportunities and workshop for cryo-EM, but there's really less and less for resin-based electron microscopy. So I will invite you to go to our website, and I will talk to you during the meeting. I do not want to use too much time to promote this, and you will find all the information. So what I'm going to talk about is another passion. Being a master gardener, I love Earth. I want all the green environment as good as possible. So I'm sure if you are like me, you probably do a lot of recycling, sorting out your garbage, and trying to get electric car, and trying to get the most energy efficient appliances. But do you ever think of doing the same thing in your lab? Okay, so this is one of the studies that done in Groningen University in Germany. So what they did is they follow 6 chemistry labs and follow how much energy they use and how much waste they produced. And they produced throughout, I think, the period of 6 months. So what they found is actually most of biological labs are not earth-friendly at all. We are doing something opposite than when we decide to come in this career. We want to improve human health, want to do something good to make life better. But we are actually, in the same time, we are actually doing a lot of pollution. We have very big carbon footprints. And so this is what this paper is all about. So they find out that the film pool is one of the huge energy consumption in most of biological labs. And the annual carbon emission per person, the global is 4.4 about tons. And US, we are like almost 3 times more than other people. And the labs, even more. Researchers, we work related, we generate another 10 to 37 tons of carbon emission for our work. Okay, so in laboratory research, we also use a lot of disposable single-use plastic waste. And a lot of time people think, oh, we are recycling. But people do not know true plastic recycling is not true recycling, because plastic does not degrade. They will stay. Basically, it's down cycling. So you get the plastic, they try to make it into rug, some floor material, but it's still plastic. At the end, it will end up in our environment, becoming microplastic. You probably heard a lot about microplastic, that they find it everywhere. Right now, I think they predict that we all carry probably some percentage of microplastic in our bloodstream, everyone, like including animals, insects, fish, everything. So this paper, they analyze all these things. They also talk about attending conferences. Okay, so they said attending conference because flying takes a lot of, it's a very energy intensive. So that also contribute a lot of the carbon footprint that we generate. So I know we cannot avoid not to use plastic, but I think just little practice can reduce the amount that we use. Okay, so this is why I'm presenting this. It's kind of a behavior changes. Okay, so in America, most of us, convenience is very important. Single-use plastic, you grab a bottle of water in a conference, okay, and it's so easy instead of dragging a mug everywhere you go. And that's really on the expense of on the earth. Sorry. Yeah, here. Okay, so I just want to remind you, we can do little things. Little things we do can gradually accumulate and make some big difference. I'm just going through a few things that focus on water conservation and energy conservation and waste reduction, which is really relevant to what we do every day, and also resource management. So this is what sustainability is, a little bit different than Green Labs. You will see a lot of that Green Lab initiative that going on. There's at least 2 nonprofit foundations focused on promoting Green Labs. But for sustainability, it actually emphasize resources too. That includes human resources, us, how we can work more efficient, because we all suffer probably staff reduction, layoff and budget reduction. So if we can conserve resources and manage our resources much better, we can also go much longer with less resources. So I'm just going through very quickly some recommendations. I know a lot of you have to follow these golden lab rules for clinical samples. Just think of little things you can do, okay? So I'm just pointing out some of the very big energy consumption that in our lab. One is in most of our labs, autoclave, film hood, okay? So even producing DI water, okay? So the things that they recommend, just using autoclave, you only use it when you need it. A lot of labs, they just routinely put everything in autoclave, even when they do not need sterilized glassware, okay? So I think this is something we need to consider. Do we really need this autoclave, okay? And same thing for using pure water. Do you really need the purest water? Can we just use with the second grade water because that is cheaper to produce, okay? And you simple things to install those low flow aerator in your faucets, fixing leaks. I'm sure you've seen your faucet dripping in your lab very often, but we just don't do anything. And one of the concepts that a lot of times when I talk to people about this, they say, I do not care. I'm not paying the utility bill, okay? But someone is paying. It's maybe your children, the next generation, is also the Mother Earth is paying whatever waste that we are doing. Okay, so energy conservation, again, we leave so many things on all the time. Ovens, my lab used to have 3 ovens. Do we really need 3 ovens? No, so I actually shut one off. We never really missed it. Okay, so try to think if you can shut something off when you go at night, okay, or on weekends, because all these things leaves on, they keep burning using the electricities, okay? And the other thing is the freezers. When I was in graduate school, the freezer standard is -70. But why do we move to -80? I do not understand, because a lot of the things we store in the -70, in the -80, do not really benefit from being in -80. So they can do fine in -70. So if you're just warming up your freezer at 10 degrees, you are saving 30% of energy. Okay? So these are something we can do easily. Okay? And probably, maintain your storage. If your freezer jam-packed and has all kinds of frost, serve as an insulator on the freezer, it's time for you to defrost. Okay, so these are just simple things I'm reminding people, changing some light bulb into LED, okay, and just encourage others to change their practice, okay. So waste reduction. If you work with EM, you know a lot of our chemicals need to be collected. They need to be collected as a hazardous waste. And again, you are not paying the bill for hazardous waste treatment. But I have helped when I was in Carnegie. I was actually in charge of the waste disposal. And I realized, wow, that is so expensive when they dispose chemical waste. So again, there's a lot of talks about replacing UA into something more environmental friendly, sensing for organic solvents, and try to replace into non-hazardous chemicals so you can reduce the amount of money and the treatment that we do with these hazardous chemicals. So resins, I know we've been using EPAM forever and ever. So right now there's newer low viscosity resins that they are alcohol compatible, so you don't actually need to go to acetone or propylene oxide. And you use refill tip boxes. Most of us are doing it already. Okay, and you use the chemical. You do not prepare a large quantity. My lab, every time, they always make 100 ml when you only need 5 ml. I said, why do you make 100 ml? Oh, because it's just easy. So and then the rest of them goes in the waste. Okay, so these are just something that we need to try to help people to think. There's some easy alternative we can talk about. So with UA, so there's years people talking about UA. Is it radioactive? Does it need to be collected as a radioactive waste? And I think different institutes has different policy treating UA. In Europe, there's a lot of labs, universities, they are banning use uranium acetate because of they claiming this radioactive. So there are several, so I'm listing several papers publishing on UA alternative chemicals that you can try. Okay, I know some of them, they work for resin embedded sample. They may not be very good for negative staining. So this is a new paper that just published, the last one here, just published recently. So they systematically tested, I think 7 or 8 alternative chemicals. They tested them both for negative staining and resin embedding, and using both like a lipid droplet or different nanoparticle sample. They have a systematic study, and they list a table to tell you which one works with which. So it's a long paper. I'm trying to get this speaker to come to give a talk in BioEM Talks. And so she presented in a webinar in Europe. So I'm trying to get her here. But if you have time to look through this literature, this paper, it's a very systematic study with all the information there. So that's one of their paper, that one of the figure I just copied it here. Okay. So, and also there's paper talking about more environmental friendly solvents. And again, this is a table comparing the alternative organic solvent you can use in your lab. So they rate them by if they are hazardous or they are more environmental friendly. Okay, so I'm not going to go through all this. I want to jump into the resource management. That's the last bit that Green Lab often do not emphasize. So the resource management is really relevant right now because a lot of us are facing budget cut. For instance, my lab, I have half the amount of the staff than the previous before I joined. Okay, so how do we do the same amount of work or even more work with less money and less people? So this is, again, some of the measures that we can do. Okay, so we are trying to get most of the instrument. If I want to buy, I first look if it's in surplus, if it's available. If I want to have some chemicals, again, I go through, we have an email list, we call it chemical spam. I can ask anybody, do you have this chemical? And I can borrow instead of buying a brand new bottle. Sharing freezer space, I do not need that much freezer space, so I do not have a designated freezer for my lab because empty freezer actually takes a lot of energy. So I just sharing one shelf from my neighboring labs. Okay, and we also are thinking about streamline EM sample processing because I have less staff, and when we have a lot of sample processing accumulated, we have to do overlapping processing. We have to streamline, so we cannot use exactly the same protocol for everything. So what I'm doing is we have a protocol, we call it rapid processing for very small size samples or monolayer cells. And so this protocol we can finish in a day instead of taking 2-3 days following the traditional embedding method for tissue. Okay, we are also trying to eliminate the need for UA and lead staining by using a quick digital enhancement. With a digital camera, you're going to see that sometimes just a quick brightness and contrast adjustment will give you something look like it's been UA and lead stained. Okay, so I'm not telling you to convert completely. We still do UAN and LED when it's necessary, but a lot of time when the user needs result very quickly, they are collecting intermediate data. We give them data as soon as possible. Okay, so that helps us our workflow reduce the time my staff had to spend on the bench doing UA and LED staining. Okay, so we are also trying to cut reagent volume. We used to have one protocol for everything. So right now, when we cut down the reagent volume, we cut it. So then we can use less hazardous chemicals. And we are also adopting some automated sample processing, which I'm not going through these because I think later on in the meeting, we have somebody talking about automation. So I'm just sharing with you one of the quick rapid processing workflow that we do. So you can see we reduce most of the time to 20 minutes instead of 60 minutes. And so to do rapid processing, you need to have vigorous shaping. That's important. So there are several little steps you can use: centrifugation, quick shaping, or microwave that can help you with reducing the time required for infiltration. Also, we have adapted into several low viscosity resin, which also you can reduce the time required for infiltration. And most of those resins are often compatible with alcohol, so we can stop after 100% alcohol instead of going through acetone or propylene oxide. So here's an example of we just using a simple ImageJ. So ImageJ, if you know how to do a very simple automation, you can even do batch enhancement. So we can just quickly get the images and send it to the user right away. Okay, so here is a comparison of the resin. We are adapting Spurs and Keto 651. So Keto 651 is a resin that's compatible with alcohol, even with water. Okay, so they are even lower viscosity than Spurs. Spurs, the CPS is about 60, so Keto 651 is about 50 CPS. It's a very easy resin to use, and so this, I'm just giving you a recommendation. Maybe you can consider sometimes using low viscosity resin that enhance your workflow, makes things go faster. So there's several generations of automated sample processing we were talking about during one of the meeting. Is these automated machines going to replace us? The answer is no. Okay, so they are very good because most of the EM processing is what? Liquid exchange. So these things can be easily adapted in a robot. Okay, so in my lab, we do not use robot for everything. So for resin infiltration, we still take it out and finish it manually. So the current model of robot is still kind of limited because they cannot process flat sample, they cannot process cover slips. But for tissue pieces, you can easily adapt it into the automated processor. I'm not going to advertise for them. So I think, as I said, we have talks coming up. We can discuss about how I know several clinical lab has been buying this automated processor, trying to incorporate them into their workflow. Okay, so BioEM Talk actually did a survey for lab sustainability. So what we found is most of US labs are doing very little. Not only just the labs, the institute themselves, they are not promoting sustainability practice. Okay, so you can see the energy sustainability practice. The majority of the EM labs are not doing anything at all. Okay, sustainability for water, nothing. And then if you look at the institution wide initiative, there's very little institutional effort trying to promote sustainability. So that is really a shame. Okay, so that's what I thought. The more people know about it, the more we can push for it. And because it's not that difficult. And it's just some little things about turning down your freezers, okay, shutting down your instrument, and all this effort will add up. Okay, so we are going to set up another session, BioEM Talk, in July. So we are inviting several schools. One of them is Penn State, the other one is University of Georgia. They all has very extensive sustainability lab practice. So they're going to share with us how they did it in their universities. Okay, so as I said, BioEN talk, we also talk about lab management. So if you want to convince your institute to help you to install some energy efficient instrument, for instance, you want to get a more energy saving freezers, and then your administrator told you, no money, okay? So there's ways you can talk to your administrator, try to convince them how to change their mind to help you to initiate those type of sustainability practice. So we have to learn how to talk to administrators because they control the pocket of the money. And so you have to use the right argument, okay? You have to think from their side, and you have to use a very positive way. And one thing is you have to start with small number. So when you want to convince people to practice, you do not tell them, we cannot use any plastic at all. So maybe you can tell them, can we just use 10% less? Okay, and something like that, easy, small steps, okay? And the other way to convince to get some investment in some big measure is to use a reverse financing strategy, is by convincing them how much money you're going to save in the future. For instance, installing a solar panel or getting a new freezer, and that ask them, can I use that money saved to buy the freezer now? And sometimes that argument can work, okay? So, as I said, I'm not the one initiated the Green Lab. So there's several foundations are really pushing forward, spearheading this effort. So one is called My Green Lab, and the other one is the Green Lab. Okay, so you go online, you will see they have all kinds of information provided. They'll be happy to provide seminar to talk to people in your school or in your lab. They also have this freezer challenge, and they want to ask people, whoever can save energy, you can save a lot of energies if you just turn down 10 degree, 10 degree of your freezer. So they have certificate offered, and then some schools are recognized with this type of practice. So this is how you can convince your administrators to contribute toward sustainability practice, because we really need institution-wide promotion for this to work. Okay, so some facts to remind you that you can see. Sometimes I just tell you you're going to save how much, but the number matters. So if every lab in the United States turn out one piece of equipment, that can save equivalent to 4,000 people's energy, okay? And 5.5 million tons of plastic waste, that's how much we produce, that equivalent 2% of the global plastic waste, okay? And fume hood, if you just close down your fume hood door when you are not working at night, that also reduces the flow rate. That also can cut down a lot of energy consumption, because at night you are not there working, okay? So warming a freezer to just 10 degrees, you can reduce energy consumption 30%. And switching your oven, that's something that's very easily done, okay? So I'm going to give you these references, and I know you may not feel free to take pictures, and you can find all this information at BioEN Talk website too, okay? So I'm going to end up here. Thank you for listening. I hope that you will all join my effort to make our Earth remain green, and then we can contribute to the really global health. Thanks.